The 150 HP case steam engine, or 150 case road locomotive, is the largest steam traction engine ever built, first produced in 1905 by the Case Company. Weighing 34,000 kilograms, it could pull over 30 plow bodies and holds a Guinness World Record for its size. In 2016, Anderson Industries completed the first full recreation in over a century, unveiled in 2018 at the James Valley Thresher Show. Tested using a pony brake, the engine has demonstrated immense power, including pulling 44 bottom plows and hauling 4 engines uphill, solidifying its place in steam power history.
Anderson's 150 horse. 700. Almost that, 700. 193. Yes, I hear that. 750. 192. 800.
The Keystone Driller, built by the Keystone Driller Company, is a steam-powered early well drilling machine used in the early oil, gas, and water industries. Known for its mechanical complexity and constant motion, it reflects the engineering innovation of its era. At the 2015 Badger Steam and Gas Engine Show, it showcased the craftsmanship and durability of historic industrial equipment. The Keystone Driller, built by the Keystone Driller Company, is a steam-powered early well drilling machine used in the early oil, gas, and water industries. Known for its mechanical complexity and constant motion, it reflects the engineering innovation of its era. At the 2015 Badger Steam and Gas Engine Show, it showcased the craftsmanship and durability of historic industrial equipment. The Keystone Driller, built by the Keystone Driller Company, is a steam-powered early well drilling machine used in the early oil, gas, and water industries. Known for its mechanical complexity and constant motion, it reflects the engineering innovation of its era. At the 2015 Badger Steam and Gas Engine Show, it showcased the craftsmanship and durability of historic industrial equipment. The Yanmar diesel engine Type K4 is a historically significant small diesel engine produced at the turning point of the company's identity. This particular model carries a maker's plate marked Yamaoka Internal Combustion Machines Company, the former name of Yanmar, before it officially changed to Yanmar Diesel Company on February 29, 1952. Because the Type K4 first went on sale in February 1952, engines bearing the old company name are considered early production units, offering valuable insight into the transition period of the manufacturer. Rated at 4 horsepower at 900 revolutions per minute, the Type K4 is a compact, robust single-cylinder diesel engine designed for agricultural and light industrial work. Its construction reflects Yanmar's early engineering philosophy: dependable starting, economical fuel use, and durability suited to Japan's post-war rural economy. Manufactured in Chiyomachi, Kitaku, Osaka, the engine played a role in mechanizing small farms and workshops across the country. This particular K4 unit was observed at the 2015 Izumozaki Engine Show, where it stood as a well-preserved example of early 1950s Japanese diesel technology. Beyond its mechanical value, it represents an important chapter in Yanmar's evolution from Yamaoka's workshop into a globally recognized engine manufacturer. The EMW Benzol motor type AN6 is a rare and beautifully preserved example of early 20th century stationary engine technology. Built by EMW Eilenberger Motorenfabrik Max Alverdes in the province of Saxony, this model delivers 6 horsepower at 500 revolutions per minute and features a single-cylinder, 4.2-liter displacement. According to the original factory documents, this particular engine was manufactured on the 9th of December 1912, making it an authentic historical piece from the pioneering era of internal combustion machinery. This engine, bearing motor number 911, was acquired from its first owner in Hertzberg and has undergone a thorough and careful restoration. Today it runs remarkably smoothly, demonstrating the durability and precision of EMW's engineering. The AN6 uses an IOE, intake over exhaust valve arrangement, with the exhaust valve positioned above the intake valve. The fuel system includes an adjustable Benzol regulator that allows the operator to set the gas mixture, while the float chamber ensures stable fuel supply. Key mechanical components, such as the camshaft, tappet, and centrifugal governor, are all exposed, giving a clear view of the engine's working cycle. Cooling is provided by a 200-liter water tank, which is sufficient for up to 8 hours of continuous operation, and even longer in cold weather. In this setup, the engine drives a lathe, supported by a small workbench equipped with a vise and essential tools for on-site maintenance. Despite the cold ambient temperature only around 3 degrees Celsius, the restored engine warms up steadily and eventually runs with clock-like precision. At a working temperature of about 10.5 degrees Celsius, the regulated speed remains stable, demonstrating the reliability for which EMW engines were known. Overall, the EMW Benzol Motor AN6 stands as a remarkable testament to early German industrial craftsmanship and mechanical ingenuity. The GSM twin-cylinder 22.5 HP engine displayed at the Cool Spring Power Museum is a notable example of early stationary power technology. Featuring twin flywheels and a two-cylinder layout, it reflects the robust engineering of its era. The bright red paint and polished brass fittings indicate careful restoration for exhibition. Mounted on a mobile wooden and metal frame, the engine could easily be moved for demonstrations. In the photograph, the blurred flywheels suggest that the machine was running, highlighting its operational condition and offering visitors a vivid glimpse into historic mechanical craftsmanship. It preserves important industrial heritage for future generations. The Crossley HH11 is a remarkable example of early heavy-duty stationary engine design, representing the robust engineering standards of Crossley brothers during the first half of the 20th century. This large single-cylinder diesel engine has a displacement of 37.067 liters, making it one of the more substantial power units produced for industrial and agricultural applications of its era. With a bore of 304 millimeters and a stroke of 508 millimeters, the hydrogen hydride delivers a slow-turning but highly reliable performance typical of large stationary engines. Rated at 67 brake horsepower at 270 revolutions per minute, the engine in many restored examples often runs at around 105 revolutions per minute, demonstrating its ability to operate smoothly at very low speeds. This slow and steady operation made it ideal for driving generators, pumps, mills, and other continuous duty machinery. Despite its size, the engine is exceptionally fuel efficient for its class, consuming only 950 cc of fuel per hour. Although primarily a diesel engine, it is also capable of running on gasoline when required, offering flexibility in remote environments. One of its most impressive features is the massive 2,160 millimeters flywheel, which ensures stable rotational momentum and smooth power delivery. Combined with its substantial weight of approximately 7,500 kilograms, the HH11 is firmly anchored during operation, reducing vibration and mechanical stress. Today, surviving Crossley HH11 engines are cherished by collectors and museums, where they continue to demonstrate the durability and ingenuity of early diesel engineering. Their continued operation stands as a testament to Crossley's legacy in the development of reliable stationary power systems. The Crossley O120 is a remarkable example of early stationary diesel engineering, produced by Crossley brothers around 1923. Designed as a robust, water-cooled four-stroke engine, it features two large cylinders and an impressive 6-ton flywheel that ensures exceptionally smooth and steady operation. With a massive displacement of 562 cubic inches, the O120 delivers 138 brake horsepower at just 260 revolutions per minute, demonstrating the slow speed, high torque performance characteristic of early industrial diesels. Originally, this engine played an essential role in the Sydney powerhouse, where it generated electricity during the early decades of industrial electrification. After its service there, the O120 was repurposed for more localized industrial applications, including powering equipment in a butter factory and later providing reliable energy for irrigation pumping. These transitions highlight its durability, adaptability, and long working life. As a stationary power unit, the Crossley O120 represents the engineering philosophy of its era: heavy construction, dependable mechanics, and efficient diesel combustion. Today, surviving examples of this engine stand as important historical artifacts, illustrating the technological progress that laid the foundation for modern power generation and industrial machinery. The Junkers Jumo 205C was an innovative German 6-cylinder, liquid-cooled, two-stroke diesel aircraft engine developed in the 1930s. As one of the few successful aviation diesel engines, it stood out for its opposed piston layout, eliminating cylinder heads and using two crankshafts to drive its 6 dual-piston cylinders. This compact and efficient design delivered about 600 horsepower continuously at 400 revolutions per minute and up to 700 horsepower for takeoff. High-pressure fuel injection, achieved through twin pumps, ensured precise combustion, while its liquid cooling system, first water, later glycol, provided stable operation and excellent reliability for long-range aircraft. The National Oil Engine KB, rated at 13 brake horsepower, is a classic stationary engine valued today for its robust engineering and smooth, reliable operation. Designed for small industrial, agricultural, and workshop applications, it represents an era when slow-running oil engines provided essential power for pumps, generators, mills, and general machinery. One of its notable features is the Dynastart starting system, which combines an electric starter and generator into a single compact unit. This allows the engine to be spun up effortlessly during starting and then to charge its electrical system during operation, offering both convenience and versatility. Built with a sturdy crankcase, a large flywheel, and a simple fuel system, the KB engine delivers steady torque at low speeds, making it ideal for continuous duty tasks. Its dependable combustion and cooling arrangements ensure long service life with minimal maintenance. Today, restored examples can often be seen running at vintage engine rallies, where enthusiasts admire their characteristic sound, slow rhythmic firing, and mechanical elegance. The National Oil Engine KB stands as a fine example of early 20th century engineering craftsmanship. Titan 3-horsepower stationary engine, built in 1910, is a classic example of early gasoline engine engineering. Designed as a reliable power source for farms and small workshops, it features a hit-and-miss governing system that efficiently controls speed under varying loads. The engine is equipped with a flick magneto for dependable ignition and a zenith carburetor that ensures steady fuel delivery. Operating smoothly at 100 to 140 revolutions per minute, the Titan demonstrates the slow, rhythmic performance typical of engines from this era. More than a century later, it remains an impressive piece of mechanical heritage, valued by collectors and enthusiasts alike. The Ford Flathead V8, produced from 1932 to 1953, was the first affordable mass-produced V8 engine. Its simple side-valve flathead design offered reliability and low cost, making powerful engines accessible despite airflow limitations that reduced performance compared to later OHV engines. A 25 HP Ohio stationary engine represents one of the most powerful examples of early American hit-and-miss technology. Built by manufacturers such as the Springfield Gas Engine Company in Springfield, Ohio, it reflects the engineering progress of the late 19th and early 20th centuries. With its substantial 25 horsepower output considered high for the era, this engine was designed to handle demanding, continuous workloads in rural industries. Its hit-and-miss governing system controls engine speed by allowing the engine to hit when power is needed and miss when the set speed is exceeded. This creates the iconic uneven rhythm that enthusiasts immediately recognize. Thanks to this simple yet effective mechanism, the Ohio engine delivered dependable performance while conserving fuel. Historically, these large stationary engines powered heavy equipment such as irrigation pumps, wood saws, and early electrical generators, supporting farms and workshops long before rural electrification. Today, a surviving 25 HP Ohio hit-and-miss engine is considered a rare and valuable piece, far less common than the smaller 1.5 or 3 HP models typically found in collections. The Slavia 4 to 5 horsepower petrol-paraffin engine from 1930 is a classic example of early 20th century stationary power technology, valued today for its reliability, simplicity, and historical significance. Built in Czechoslovakia, the engine reflects the solid engineering tradition later associated with the Skoda works. Designed as a single-cylinder, low-speed unit, It was widely used in small industries and agricultural operations, where dependable power was essential for driving machinery, pumps, and generators. A defining feature of the Slavia engine is its dual-fuel capability. Like many engines of its era, it was designed to start on petrol, thanks to petrol's easier ignition at cold temperatures. Once the engine reached operating temperature, the operator would switch it to paraffin, kerosene, a cheaper and widely available fuel. This transition not only reduced operating costs, but also demonstrated the clever, practical engineering solutions of the time. Rated at 4 to 5 horsepower, the engine delivered steady and efficient performance suitable for rural and workshop environments. Its rugged construction, exposed moving parts, and characteristic slow-running sound make it highly appreciated by collectors and vintage machinery enthusiasts.